Alright, so the very first problem that I want to go over is that Samuel fell asleep problem way back in chapter 1. So we're going back a little bit, but we've got to address this issue. So this was on page 10. It was on page 10, right, because it's from chapter 1, and this is exercise number 3, right? It's the Samuel fell asleep problem. So, in fact, let me put this under the doc cam so we can read it together. It says, Samuel was riding in the back seat of the station wagon on the way home after a long and tiring day at the beach. He fell asleep halfway home. He didn't wake up until he still had half as far to go as he had already gone while asleep. How much of the entire trip home was Samuel asleep? So, okay. So a lot of people got 1/3 and a lot of people got 1/4. And so I split you up into groups, and I tried to split the groups evenly so that there was a good mix of people who got 1/3 and a good mix of people who got 1/4. And I was hoping that you would kind of battle it out to see who was right. And what ended up happening is that the people who got 1/4 ended up convincing most of the people that 1/4 is the correct answer. And that's too bad, because the correct answer is 1/3. The correct answer is 1/3. Okay, so let me show you kind of the reasoning that I saw behind the 1/4 answer, and then we'll talk about why that's not correct. Okay, so it says Samuel was riding in the back seat of the station wagon on the way home after a long and tiring day at the beach. He fell asleep halfway home. So a lot of people wrote out a little timeline kind of like this, and they said, so if this is the beach and this is home, then they said he fell asleep halfway home, right? Fell asleep, right? About halfway home. And then it said he didn't wake up until he still had half as far to go as he had already gone while asleep. Now that phrase is a little tricky, and if you got 1/4, it's because you didn't read that phrase carefully enough. Okay, because if you got 1/4, it's because you read the phrase like this. You said he woke up when he still had, halfway to go, or something like that, right? That's kind of what you were thinking. And so you're thinking, well, so halfway between the time he fell asleep and the time he got home is right here, so this is when he woke up. And then the question is, how much of the entire trip was Samuel asleep? So he was awake here, right? And then he fell asleep here, and then he woke up there again, so he was awake here. So here he's asleep. It's during this portion of the trip. And so you thought, well, how much of the trip is that? Well, if I split this place in half, then I can see that clearly that's 1/4 of the trip. And so you said, oh, that's 1/4. So you got 1/4 as your answer. Okay, now here's why that's wrong. It's because that tricky phrase, that's in italics, right? And that's the reason it's in italics, is because it is tricky, right? It says he didn't wake up until he still had half as far to go as he had already gone while asleep, right? So it's not like he had, I don't even know how you would phrase it. It's not like he, woke up. It's not like he had half as far to go as he had to go when he fell asleep. In other words, they're not saying like it's not half as far to go as from this point when he fell asleep. It's he still had half as far to go as he had already gone while asleep. So if you think about, well, how long did he travel while he was asleep? Half of that distance is how far he still has to go when he wakes up. So let's draw this timeline again. Okay, beach, home, he falls asleep halfway home, right? Fell asleep. But then when he wakes up, he needs to have half as far to go as he went while he was asleep. So however long he went while he was asleep, he needs to have half of that distance, right? So half of that distance still to go when he wakes up. Right, so he wakes up here. Okay? So this is the portion of time that he was asleep. Okay? So notice now the way that we've drawn it, it makes sense with what the phrasing of the problem is, because now when he wakes up, he has half as far to go as he had already gone while he was asleep. Right? So half of the time that, or half of the distance that he traveled while he was asleep is the distance that he still has left to go when he wakes up. Okay? And the question is, what portion of the entire trip is that? Well, it's not 1/4 anymore, because we didn't split this distance in half, we split it into thirds, right? So if we split this distance into thirds, then we've got 1, 6, 2, 6, 3. Well, we've split it into 6 parts, right? 1, 2, 3, 4, 5, 6. Excuse me. So if we split that distance into 6 parts, and here are 2 of them, then he was asleep for 2/6 of the trip, which reduces to 1/3. So he was asleep for 1/3 of the time. Okay, so again, it's this tricky wording, right? He didn't wake up until he still had half as far to go as he had already gone while asleep. So again, it's not half as far to go as he needed, or as he had gone while he was awake. Right? It wasn't half as far. Right? That one makes sense. If you said he still had half as far to go as he had gone while he was awake, so half of the distance while he was awake, that would be that much. And so if he wakes up, he has that much left to go. Then the correct answer would be, oh, you couldn't see what I was pointing to. Let me say that again. So this is the distance that he traveled while he was awake, right? From here to here was the distance that he traveled while he was awake. So if the problem had said when he woke up, he still had half as far to go as he had traveled while he was awake, well, then he would have 1/4 of the trip still to travel while he was awake. And since he had 2/4 of the trip while he was awake before he fell asleep, and then 1/4 after he woke up, then that means he was asleep for 1/4 of the time. So that would be the correct answer if the problem had said when he woke up, he still had half as far to go as he had gone while he was awake. But that's not what the problem said. The problem said when he woke up, he still had half as far to go as he had gone while asleep. While asleep. Okay? So when he woke up, he still had half as far to go as he had gone while asleep. Okay? So you need to take the amount of, or the distance that he traveled while he was asleep, split that in half, and then that's how much longer he has to still travel when he wakes up, which means that you would split the time between the time that he fell asleep and the time he got home into 3 equal parts. Right? Anyway, so 1/3. Now, a lot of people, now here's why I suspect that a lot of people were convinced by the 1/4 argument. It's because the people who got 1/3 were all using this equation, and I'm not sure where they all got it from, because here's the thing, in all the semesters that I've taught this class, I've never once seen a student come up with that equation, and now suddenly, like, every student who got the right answer was coming up with that equation. So I don't know if it's just like you found the problem worked out online somewhere, or you got help from like the same tutor or something, or maybe you all just worked together on the problem, and so one of you understood the solution but nobody else really did, and you were just kind of copying. Look, that kind of stuff, it's just not going to help you do well on tests and quizzes. You've got to struggle with these problems and make sure that you understand the solutions. Okay? So the equation that people were coming up with was correct. Let me see if I can remember what they were saying, so that I can try to sort of explain it. So I think a lot of people were saying, let x be the entire distance, right, from beach to home. Okay, and then I think they said let y be the distance that Samuel was asleep, I think is the way that they set this thing up. And so then they said, gosh, how did they say it? They said, uh, hmm. How did they set this up? Here's the thing, like, I don't think that you can even set up this equation very well unless you have something like this in mind. Maybe you didn't actually draw it out, but it's like you have to have some understanding of the problem, which would require you to have something like this in your mind's eye, I suppose. But let's read the problem. So Samuel was riding in the back seat of the station wagon on the way home after a long and tiring day. He fell asleep halfway home. He didn't wake up until he still had half as far to go, as he had already gone while asleep. Yeah, I'm not even sure. I'm gonna have to look up the equation that they came up with. Maybe this isn't what they were saying. Let's look at it together. We'll look up one of these discussions. Not to embarrass anyone, but I just want to see. So where would it have been? In the Samuel fell asleep thing? So we'll look at, I don't know. I don't remember who's all in what groups. Okay, so Cody, he says, y plus 1/2 times y equals 1/2 times x. So he's saying, so let me write this down. Y plus 1/2 times y equals 1/2 times x. Okay, so let's see. So, so if x is the entire distance, then half of the distance is from the beach to the time that he fell asleep. That would also have to be the time from the time he fell asleep until the time he got home, right? And then he's saying y, which is the distance that he was asleep. So y plus half y. Got it. Yep. Okay. So that makes sense, right? So you're saying the half of the entire trip we can call 1/2 x, right? If x is the entire trip, then from here to here is 1/2 x, right? 1/2 times x. Okay? Because that's half of the entire trip. And now if you, so that's if you count this entire distance. But now if you count the little pieces, it's like if you add up the time he was asleep, and we're calling that y, and then he still had half as far to go as when he woke up as he had already gone while asleep. So this little piece would be 1/2 y. So this is y, and this is 1/2 y. So then y plus 1/2 y would have to equal 1/2 x. Okay, so that's where they're getting the equation from. And then the question is, you know, what distance, what portion of the entire trip is the distance that he was asleep? So in other words, if you solve this for y, then you know you would get 3/2 y equals 1/2 x, and then you could multiply by 2/3 to solve for y, and the 2's cancel, you get 1/3 x. And so there you go. There you see it again, that the distance that he traveled while he was asleep is 1/3 of the entire distance, right? It's 1/3 of the entire trip. Anyway, but you've got to be able to set up this equation. The only way you can do it is if you really understand this. Again, maybe you didn't draw the picture. That's okay. But you probably had something like this in your mind's eye. It's like you had to somehow be able to reason like, okay, so the distance that he traveled while asleep, when he woke up he still had half that far to go still, so the distance he traveled while asleep plus half of the distance that he traveled while asleep, that needs to make up half of the entire trip, right? Anyway, so that's that idea. It's just kind of a fun problem, but I'm a little dismayed that that the 1/4ers out there kind of convinced you one-thirders. But I think, again, I think the reason it happened, or I think the reason that happened is because a lot of you wrote this equation down without really understanding where it came from. I think you were copying from someone or something online maybe. But anyway, so that's that. Hopefully that clears things up for you a little bit.